This is the sixth video of the tutorial about history analysis in RayJack ONE. In this video, we will learn how to use the interaction logs to evaluate the details of the ray surface interactions for a ray tracing simulation in post-processing. In the previous videos, we have already seen how to inspect the paths for a ray tracing simulation. And while the paths allow us to see the sequence of interacted objects together with the corresponding interaction types, the interaction logs will provide us with a more complete description of the individual ray surface or ray volume interactions. Besides the interacted objects and the interaction type, the interaction logs also contain the interaction positions, the ray directions for each interaction, the ray flux, the surface normal, the medium, the optical path lengths, and several other properties. In order to use interaction logs in your RayJack ONE script, it is recommended to set up the history detector to record all interaction data with the following command: history.settings.recordAllInteractionData equals true. With these history settings, we rerun the ray tracing simulation. Once the ray tracing is finished, we can obtain the interaction log. Let us pick the first ray in the ray collector. For this ray, we can get the interaction log with the command history.getInteractionLog, and then we provide the ray as the input argument. We can imagine the interaction log as a list of individual interaction records, each describing one ray interaction. We will loop through the interaction log to print the individual interaction records for the given ray. This allows us to see the sequence of interactions, starting by creation in the grid source, transmission through the lens front, and for each of these interactions we can see the position, the direction, the flux, and so on. In order to demonstrate the flexibility with which the interaction logs can be used in ray tracing post-processing analysis, I would like to show you how to generate a visualization of the hit points of the rays at the front surface of the telescope, where each of the hit points is colored with regard to the angle of incidence. We start by initializing 3 lists of hit points. One list for hit points with an incident angle below 30 degrees. One list for hit points where the incident angle is between 30 and 60 degrees. And one list of hit points where the incident angle is between 60 and 90 degrees. Next, we loop over all rays in the history detector and evaluate the corresponding interaction logs. For each ray, we loop over the interaction records in the interaction log. We use the enumerate command, and you will see in a second why. Remember that we are interested in the hit points at the front surface of the telescope. First, we therefore compare the name of the interacted object with the name of the surface that we are interested in. If record.interactedObject.name equals lens 1 front. And for these relevant interaction records, we now evaluate the interaction position, the surface normal, and the ray direction. But note that the field record.direction refers to the ray direction after the ray surface interaction. As we are interested in the angle of incidence, we therefore need the field record.direction of the previous interaction record. We get the previous record from the interaction log at index II-1. And the angle of incidence, or the ray direction of incidence from the previous record's direction. The angle of incidence is now given by the surface normal and the ray direction. We want to constrain the interval of angles of incidence between 0 and 90 degrees. So if the angle is larger than 90 degrees, we want to apply the following correction. Now we can sort the interaction positions into the three lists of hit points based on the value of angle. For angles larger than 60 degrees, we put the hit point position into the list HP90. If the angle is between 30 degrees and 60 degrees, we put the hit point into the list HP60. And finally, if the angle of incidence is below 30 degrees, we put the hit point into the list HP30. Now that the hit points have been sorted into the three lists of hit points based on the angle of incidence, we can visualize the hit points with different colors. The hit points with an incident angle between 60 and 90 degrees should be colored in red. The hit points between 30 and 60 degrees should be colored in orange. and the hit points below 30 degrees should be colored in yellow. Let us run this section of the code. And this is how the result looks like. As we can see, the hit points are plotted over the front surface of the telescope, and each hit point is colored depending on the angle of incidence that the ray had when it interacted with the surface. So in this video, we have seen how we can use the interaction log to study in detail the ray surface interactions of a ray tracing simulation.